Okay, so first of all, hello friends. So today we are going to discuss database concepts. So I already marked it as done. So today we'll discuss all the database concept in our high level design. So if you are new, so this is a high level design series. So we discuss all the steps, all the concepts, like key concepts, and then we are at building blocks now. And after that, after completing these building blocks, like I think in a month it will be covered, and then we're gonna discuss important thing, that is trade-off, right? Which is very important in our seniority level things, right? And then we're gonna discuss uh, patterns, and then we'll switch to LLD designs, like low level design, which is very important in our day-to-day interviews. So first of all, let's clear our high level concepts. If you're new, so you can go through all the other YouTube videos, or you can read here in this repository. I have added all the notes as well for all the design concepts, and in the building blocks all the concepts, so I added this as well. So like I always store the notes, right? If you go through, if you forget, then you can go through here as well. So let's start our database concepts. So I created some notes here. So here, if you see database scaling, we want to discuss scaling, replication, redundancy, sharding, database architecture. So out of these, the first one is important, database scaling, and sharding is important because it's a very important. Actually, let me get my pen first. Okay, so uh, like scaling is important, right? This is a kind of conceptual thing, but sharding is very important. This is your day-to-day activity in your company, right? In if you are working in a big company, then you will see sharding, right? Okay, let's start. What is what it says? When you build a small application like 100 users, a single database server is usually enough. But when we are growing, when we are server, like when our user base grows like 1 million, 100 million, billion, then uh, our single database become bottleneck, right? Then we use these concepts. Okay, simple. 8 lane highway, but the bridge is single, right? Then again 8 lane highway. So this is our bottleneck. Okay, this is our bottleneck. Okay, so to solve these problems, we use like big companies use scaling, replication, redundancy, sharding, and concepts. Okay, so kind of we'll discuss just like as master slave, leader follower. We'll discuss. Okay, so simple, just a concept, right? But these two focus more. So first of all, let's start with scaling. So data scaling means increasing capacity to handle more users, more requests, more data. Basically, suppose your database is capable to handle 10,000 requests per second, right? But your application is receiving 100,000 requests per second. What you will do? So we have two types of scaling: vertical scaling, horizontal scaling. So basically, in vertical scaling, what we do, just like as I just draw a vertical thing. Suppose you have four uh, cores, right? Four cores, 16 GB RAM. It's a processor, right? I'm just giving real life example, right? Vertical scaling means increasing capacity. Instead of four cores, you can implement 16 cores. Instead of 16 GB, you might use 64 GB. Okay, so this is our vertical scaling. Okay, now make the existing server more powerful. Simple. Oh, same example I gave you. Storage I missed. Like doesn't matter, right? 500 GB, you can make 10 TB, right? Simple. I have given real life example. We have one in a restaurant we have one chef. Now customer increases, you can hire a super chef who cook faster. Okay, that's a vertical scaling. Now let's see some disadvantages and sorry, advantage first. Simpler, no architecture changes, just a hardware update, simple, easy management, one database server. That's it. Disadvantage, expensive, powerful server cost a lot, right? If you're increasing from 4 cores to 16 core or like 16 GB to 64 GB, it increase cost. Like cost is increasing horizontal server as well, but we can we'll discuss. We can remove servers, upgrade server side, but here if we are removing 4 cores to 16 core, then the cost is permanent. Okay. And again, one more disadvantage, hardware limit, right? We can't buy infinite RAM, we can't buy infinite CPU. There's always a maximum, there's always a maximum machine size. Okay, for example, I have i5 processor, okay, and I have a maximum capacity of 8 GB RAM. Weird, na? I have 2011 laptop, still working, right? So I'm not making a video on the same laptop, but still it's working, right? It's working perfectly fine. I5% per maximum limit. I told them to increase up to 16 GB or 32 GB. They said the maximum support is 8 GB only with this laptop. So still working perfectly, but still with this, right? But the thing is, it's working very fine with Windows 7. Still have it Windows 7, original Windows 7, but it doesn't work perfectly with 11 or like above versions. Okay, so next disadvantage, single point of failure. One server means single point of failure. What single point of failure is? One component can bring down the whole system. Anything breaks, processor break, RAM break, it will bring down the whole system. Okay. Now, horizontal scaling. So usually we do horizontal scaling, right? In our day-to-day life, or right now, everybody is grasping the horizontal scaling only. Horizontal scaling means adding more servers instead of making one big server, right? Adding more servers, right? Just like as pods. We starting like for dev, 2 pods, for UAT, 4 pods, for production, 8 pods, right? So, so just like as we have multiple servers, if one pod is gone, we have one up, like 2 pod is gone, we have two up, any pod went out, still we have pods to respond, right? So real life and all the same thing, we are opening 10 kitchens, simple, right? Dev server A before and after we gonna have multiple servers A, B, C, D. Traffic is divided. Now advantage and disadvantage. Let's see. Near infinite growth, right? Need more capacity, add server. Simple. Server one. If you need more capacity, add server two. Need more capacity, add server three. Need more capacity, add server four. Right. Just like as Amazon, right? For our sorry, uh, for let's say Amazon, right? For our holiday seasons, just like a Holi Diwali, right? They increase the servers. They increase the servers, and in the regular days they decrease the servers. Simple, right? Increase and decrease. Even we don't like do like manually. It's automatic, right? Automatic means suppose we get 100 million requests per day, right? Then we're gonna use 8 servers, for example, right? Automatic concept is there. If you're gonna like receive 1 million, like more than 100 million, or in between or less than, my bad, more than 100 million, less than 10 million, we're going to use 16 servers or like 16 ports, something like that. Okay, so this is the automatic concept. It will scale up and scale down automatically. uh Next, fault tolerance. If one server fails, other are working. Fault tolerance means system continue functioning even some components fails. Okay. Best availability. Availability means system remain accessible to users like Amazon, Netflix, right? Some failure, if some server fails, it will still up. Okay. Now disadvantage. So complex, right? Now engineers solve must data synchronization, replication, sharding, consisting, which we'll discuss next. Okay. So if we have more servers, right? More server means more complexity, right? It will talk to multiple databases as well. Okay. So sometimes suppose it was talking to database, stops. Talking to database stops. So where it will be, there will be some issue with the data sync, right? So we have to manage. We have to use a lot of other concepts, right? We'll discuss. So now later, right? Now it's a again deep thing. We'll discuss in next videos, right? Data replication. Now the first was database scaling, right? Now we are at replication. Okay. So what does replication means? So this is a like general concept, right? Our DBAs do the same. Means creating multiple copies of data across multiple servers. Okay. Means primary database user ID one name John. Replication create copies in three servers. Suppose server A, B, C, same. Server A will gonna have same ID one John. Server B ID one John. Server C ID one John. Why replicate data for reliability? If one server dies, other copies still exist. High availability. User can still access data. Just like as we discussed above, Amazon, right? Have multiple servers. One server gone, then server 2 is there. Server 2 is gone, server 3 is there. Server 3 is gone, server 4 is there. Okay. So read scalability, read request can distributed, right? Meaning master slave. We're gonna discuss. So we're gonna have servers like four servers. If we have to read, so it might read like this. Okay. Server gonna read with slave one, server two gonna read with slave two, server three and four gonna read with slave three. Right. So um yeah, read means selecting data, write means write, insert, update, delete. You are modifying data. You know, right? Read, write. Generally we raise the request for read, write, write, insert, update, delete. Okay. Read is simple read. Select statement, right? You know everything. Like these simple concepts. So primary database, replica 1, replica 2, replica 3, replica 4. Read go to replica. Okay. Write go to primary. We'll discuss in our database architecture, right? So the only database replication important concept is creating a copies of data across multiple server and these data sources are accessible. Like we have three servers are live with the same data. Three servers are live with the same data. Okay. Now we have data redundancy. We'll discuss what is the difference between redundancy and replication. Storing extra copy of data to survive failures. Many beginners confuse redundancy and replication. So here is extra copies, storing extra copies. Okay. In replication, there is storing only copies, creating copies, right? Creating copies, and here storing extra copies. What does it means? Meaning replication was we are making in replica 1, replica 2, replica 3, right? This is a replication. Replication. Okay. And here we have redundancy. So we're gonna store data. These are live, right? These are live. These will be at rest state. These will be in rest state. STA state. Okay. Meaning, suppose co-op server, kind of, or DR server, right? So meaning, I'm just giving example. Suppose this is our main server, like primary server. It's working. It's live, right? And redundancy is like our database disaster recovery server. Okay, meaning the same data is here, right? Whatever data we have in live, same data is here as well, but it's at rest state. It's at rest stage. Okay, when this gonna down or might be data failure, then we can use the data from here. Fix the data, this fix data, and then we can again make it live. Okay, so difference. Replication is focused on performance and availability. Okay, performance and availability meaning live three servers, and redundancy focus on backup, fault tolerance, data recovery. Okay, sorry, disaster recovery. What I was like telling you the example. Okay, so simple example: you are storing family photos in laptop, hard drive at multiple places. Okay, so same. Now, why big company need redundancy? For history, order history, payments, customer data for millions of users. Okay, suppose we need history data, we can directly fetch it from our storage. We don't like care about our life story as well. Like lot of like advantages, right? So imagine Amazon losing all these things, but still therefore data exists in multiple locations. It means sometimes multiple countries as well. So what is data recovery? Database disaster recovery. Ability to recover after catastrophic failure. Example, data center failure, flood, earthquakes, power outage. Data redundancy helps recovery. Okay. So whatever the natural disaster or anything kind of issue occurs, then we can able to recover. So again, I think we are good with replication and redundancy. Okay. Now, very important concept came. Okay. Database sharding. Now, what is database sharding? Let's jump to the definition directly. Splitting one large. Okay. Splitting one large database into multiple small databases is called sharding. Splitting one large database into smaller multiple multiple smaller database. Each piece is called shard. Each piece is called shard, right? So I'm skipping, I'm just focusing on main points to give you understanding, right? You can read these notes later, just like as like whatever the small words I wrote, I wrote everything for you, right? I'm focusing on main parts to make you understand better, right? So what it means, let's take an example of table, right? Your ID, your name, right? So one, two, three, four. You have like a lot of details right here as well. So your name is like Abhishek, Bubbly, Sam, Yong. Okay, so sharding means we said name from A to S, we treated it as the shard one. Okay, and after S to Z, we're gonna treat it as shard two. Okay, in this way, we made two shards because we know we have lot of names in between S to Z and A to S. So we split. So instead of writing S here, write R here. Okay. So we know we have lot of names from A to R and then in between S to Z. So we split out here. So from whatever the name from A to R, we call it as shard 1. We split it out this table, right? And we store the different table will be same, but in different database, right? Different database, and we're gonna save only name from like S to Z here, different table or different tables, whatever you want, right? But different records. S to Y here, sorry, S to Z here, whatever, Semi and Yom, and A to are in different table. Okay, so this is sharding. Suppose we have lot of records, right? We have billions of records, right? So we split our table into multiple parts to make our speed fast. This is the main purpose of sharding. Okay, why sharding? Suppose we have billions of users. Single database become too large, right? Query slow down. Storage become massive. So instead of one, we're gonna create multiple shards. One, two, three, four. Each shards stores a part of data. But I have like gives example. Okay, just like as user one, user two, up to billions of users spilled by user ID. Shard one gonna have one to 2000 million. Shard two will have up to 20 to 250 to 500 million. Shard three gonna have this. Shard four gonna have this. Okay, so database handle only part of workload much faster. Imagine Instagram, right? Instead of one giant, it has multiple shards. Shard A, US users. Shard B, European users. Shard 3, Asian users. Okay, so one technical term is partition key, right? What is partition key? Partition key determines which shard store a piece of data. Which shard stores a piece of data, meaning we created four shards, kind of tables. We created four tables, right? Now, data is coming. Data is coming, but data will store in which shard? Here in one, two, three, four. Where data gonna store? Okay, so that will be decided by partitioning key. That will be decided by partitioning key. Okay, so for example, we have user ID, country, region, customer ID. So user ID modulus 4 because we're gonna have four shards. Okay, four shard means user ID modulus 4. Whatever value will come, it will go in that shard. Suppose 4 modulus 4, whatever the value will come, go into that shard. Okay, 8 modulus 4, whatever the value will come, it will go to that shard. Okay, so in this way, we're gonna divide. This is called shard key or partition key. Okay, benefits of sharding. Faster query, better scalability, lower load. Okay, now again, challenge. Now think about once what will I think you already saw, right? What a challenge. So we divided the one table into four shards, right? Four shards. Now it's very simple to say, right? We are dividing into four and data will be stored easily by using some formula and then uh, it will be fast, right? But the thing is, complexity rises when we have to join all this data, right? Meaning cross shard query need data from multiple shards, right? Meaning select star from all the users. It will be complex, right? Must query many shards, mean more complexity, right? When you have to retrieve data from all the shards, it will be complex. Okay, rebalancing. Suppose shard A has 90% data by chance, shard B has 10% data. Need a redistribution, right? This is called rebalancing. So, what you learn from sharding? Dividing the data into multiple tables, like multiple databases or multiple data, whatever, with their some kind of partition key is a sharding concept, which is like even we use regularly, right? Because we have billions of data. If we, sorry, I can say if we have billions of data, then we can use sharding or we are using sharding, right? It's like real thing, right? If you have 1 billion records in one table and I need to search, doesn't matter you use indexing or whatever, but it will still take time, right? Now, database architecture, again important, right? Important to understand how database architecture is there inside our, like how they follow. The first one is master slave, meaning one will be master and then we're gonna have multiple slaves. Okay, so master will handle write operations, slave will handle read operations. You know, I think you this thing, right? Master, slave. So you know like what is right, insert, update, delete, and slave is select. We already discussed in the application, right? So Instagram profile, whatever gonna need from slaves only, and rest change bio, upload, these are rights will be handled by master only. Okay, massive read scalability. This is our advantage, but everything come with like disadvantage as well, right? Master failure. If master dies, no possibility of read until failover happens. Now, what is failover? Failover means automatically switching to a backup server after failure. If master fail crashes, then slave one become new master. User one continuously working. What it means? This is our real world analogy, right? Sorry, not R. I have to write here slave, master, slave, slave, slave. Okay, suppose it is gone, then it will take the position of master, meaning slave one will become master. It will gonna handle write operations. Okay, and two slave will gonna handle read operations. Okay, until this master backs up. Okay, so that was a master slave. Now we have one more architecture, master master architecture structure, right? Both can read and write. So no single server high availability. Okay, but again, everything comes with an issue, right? It comes with data conflict. Server A balance 100, server B balance 120. Sometimes, suppose we have master master, right? It sends the date. Sorry, it should be like this actually. Uh, okay, so this is a server, server, server. Okay, so master, master, right? It sends the request here to update the data. Meaning, suppose it has 80, it updated to 100, right? It sent again client. It will gonna have a client. Then again, the next request come here, right? It has to sync. It has to sync, but somehow sync will take time. right? Syncing will take time, right? So next will come update 100 to 120. So request come here. Suppose it's stored directly 120, right? It has 100 still, and we are reading something and read. Suppose we read from this master, right? It will return 100. So to sum up, so to sum up, both have master, both have rewrite capability. Okay, so there data conflict, right? Server A balance 100, server B balance 120, right? It took funds without replication, sorry, without synchronization. We have 100 here, 120 here, and while reading, it might return 100, or if you read from here, it will return 120, right? Because both are kind of in the same layer, so data conflict will be there. Simple. Okay, so same record updated simultaneously. Which value wins? Which value wins? This is a right conflict. Conflict doesn't become difficult. Okay, so I will explain this thing. Same record updated simultaneously. Okay, so in master we have data right conflict. So we use master slave only. We use master slave only. So leader follower architecture. This is a third architecture. This is the same like master slave only, right? So modern name of master slave. So generally, why modern system prefer master slave, meaning leader follower, simple, reliability, easy conflict management, widely used by MySQL, Postgres, MongoDB, Kafka, distributed database, right? So always, if you see the companies, like big companies, they always go with leader follower, meaning master slave. Okay, if master go on, then slave will become master. Okay, and our slaves will be handling all the read operations, master will be handling write operations. No conflict, nothing, right? This is the best design. So today we learn what we learn today, data base scaling. First concept, very important, database scaling. Then we learn replication, again important. Then we learn redundancy, important. Then we learn database sharding, very, very important. Then we learn database architecture, again important. Okay, sharding is very, very important. If you have any question, just comment on me. Scaling is also very important. If you have any questions with any concept, then put a comment. I will try to give answer soon, right? So if you are new, then subscribe this channel. I will come up with the new concept as well, meaning still we have a lot of concept to learn, right? And again, if you are new, I'm just giving you that reference again. Here I have put all the notes, right? So you can go here as well and read the notes. So today's notes is here, right? Whatever I explained, everything is I copied here as well, right? So for now, I can say take care and goodbye, and we'll meet soon again with a new concept, right? Fail over. So for now, bye and have a good day. Thanks.